Guido Tonelli, Genesis, the story of how everything began. Embark on an awe-inspiring journey through time and space as we explore the origins of our universe in the book's summary of Genesis, the story of how everything began, written by Guido Tonelli. Discover the intricate details behind the birth and evolution of the cosmos. From the emergence of particles like inflatons and Higgs bosons, to the formation of stars, galaxies, and eventually our own solar system. This fascinating account unravels cosmic mysteries, highlights the significant moments in the universe's history, and provides an incredible understanding of how everything came into existence.
From void to universe. The universe we know began as a void, a vacuum that seemed empty but experienced quantum fluctuations. These fluctuations birthed tiny particles, which at some point underwent a magnification process. One particle, known as an inflaton, dramatically inflated the vacuum bubble, creating our universe that expanded faster than the speed of light. The universe, while appearing filled with matter, maintains zero net energy due to the balance between positive energy particles and negative energy gravitational fields, reflecting its origin from the void. In its earliest state, the universe was a void, a seemingly empty vacuum. Yet, even in this mystery-laden nothingness, critical events transpired. Quantum fluctuations caused small-scale, short-lived virtual particles to emerge and vanish in an instant. One specific particle, the inflaton, played a crucial role in the birth of the universe. When this particle's field bloomed, it set off a chain reaction that inflated the vacuum beyond imagination. From an infinitesimal bubble, the void expanded faster than light speed, rapidly transforming into the vast cosmos we reside in today. Our understanding of the universe's genesis remains limited, and the closer we probe its origins, the more elusive the details become. Nevertheless, the notion of a universe born from a void holds an intriguing implication. Our universe is, in reality, a transformed vacuum. At first glance, this claim might appear nonsensical, as we can observe the tangible existence of objects, including ourselves. However, the idea of a void doesn't negate the presence of matter or energy. It implies that the universe has zero net energy, as the positive energy from various forms of matter is balanced by the negative energy of gravitational fields. Calculating the sum of the universe's energy, matter and gravity, returns the value of zero. This ties our existence back to the void, where quantum fluctuations birthed our ever-expanding cosmos. The Higgs boson's universe. The universe's initial phase, a formless sea of gas filled with massless particles, was transformed by the Higgs boson, which bestowed particles with mass and paved the way for matter development. As particles gained mass and variety emerged, the once uniform universe changed dramatically. The Higgs boson disappeared for billions of years, resurfacing only in 2010 during an experiment at CERN, confirming its existence. In the beginning, the universe was nothing more than a massless, indistinct sea of gas. This seemingly unchanging expanse was filled with particles devoid of mass and moving at the speed of light. However, everything changed with the arrival of the Higgs boson, which granted mass to particles and altered the universe forever. The Higgs boson's transformative power comes from its ability to give particles mass through contact with the Higgs field. As the particles pass through this field, their speed decreases, and they acquire mass. Depending on the extent of this interaction, particles can either gain enough mass to become unstable and perish, or they can achieve just enough mass to survive. These lighter, stable particles are the key players in the formation of matter in the universe. With the newfound diversity in particle masses, the once uniform universe evolved into a realm filled with variety. As the universe expanded and cooled over time, it became inhospitable for the Higgs bosons, which required high temperatures to exist. Consequently, the Higgs bosons vanished, not to be found for another 13.8 billion years. It was not until 2010 that the elusive Higgs boson resurfaced when scientists at CERN conducted experiments involving high-intensity particle collisions. This groundbreaking discovery confirmed the existence of what had previously been a mere hypothesis and shed light on the fundamental role the Higgs boson played in shaping our universe. Birth of light and matter. The Higgs field's importance lies in its ability to give particles mass, diversifying the previously uniform universe. Coupled with the separation of weak interaction and electromagnetic force, subatomic particles gradually achieve stable forms, laying the foundations of our material world. Among the earliest developments are the emergence of protons, serving as critical building blocks for more intricate cosmic structures. Electrons, too, have a pivotal role. As temperatures fall, these particles orbit protons stably, paving the way for atoms and molecules. One major breakthrough arises once electrons become occupied. Photons, once trapped by electron clouds, are now free to roam, illuminating the universe with unprecedented light. The birth of megastars. As the universe's development slows down, gravity becomes the star of the show, bringing about a major transformation. Gas, now acted upon by gravity, gradually leads to the formation of massive gaseous spheres, which after millions of years ignite the birth of the first megastars. These colossal stars not only forge heavier elements at their cores, but also set the stage for the formation of planets. In the current stage of our universe, the pace at which things were happening slows down considerably. From rapid-fire cosmic events happening in mere hundreds of thousands of years, the timeline now shifts to a more gradual 100-million-year span. With this change in pace, gravity emerges as a crucial player in shaping our universe. Up until this point, gravity held a supporting role in the formation of the universe. But now, as things slow down, gravity steps into the spotlight. To make its presence known, gravity needs matter to act upon, and it finds this matter in gas. Thus, gravity acting on gas opens the curtains for the birth of the first-ever stars. With the universe now consisting of atoms' essential elements, matter can start taking the shape of stable elements like hydrogen and helium in the beginning. Unequal distribution of matter across the universe creates denser pockets of material, which under the influence of gravity, attract even more matter. This gradual density increase paves the way for something remarkable. These pockets slowly become titanic gaseous spheres, developing incredibly dense, hot, and compressed cores. After millions of years, their intense heat triggers the fusion of hydrogen isotopes and results in an explosion of heat and light. This magnificent event marks the birth of the universe's first star after 200 million years. These early stars are so massive that they earn the title of megastars. But their significance goes beyond their impressive size. Inside their nuclear cores, these megastars forge increasingly heavier elements that will contribute to the creation of newer stars and eventually, planets. Birth of a galaxy. Since the universe's inception, massive fires of stars have burned out, releasing gas, dust, and heavier elements. Gravity takes hold, pulling these components together to give rise to galaxies. Central to almost every galaxy exists a supermassive black hole, including one in our own Milky Way named Sagittarius A star. These black holes take on a mind-boggling mass, millions of times greater than our Sun. However, they don't swallow everything up. Momentum keeps stars and other matter orbiting the black hole in a rotational disk. Our Milky Way, a spiraling collection of approximately 200 billion stars, is just one of the approximately 200 billion galaxies present in the universe. Here, nestled in the calm galaxy of the Milky Way, something extraordinary is about to happen. Milky Way's peaceful era. The formation of the Milky Way took place billions of years ago, and after an initial turbulent period, it eventually reached a state of stability. This period of galactic peace enabled the gradual organization of entities in ever more complex ways, leading to the birth of our solar system. Molecular clouds composed of hydrogen, helium, and other elements condensed to form our Sun and the planets that orbit it. One of these planets, Earth, developed a gaseous atmosphere and eventually harbored life in its oceans. Over billions of years, life grew in complexity, giving rise to the human species, capable of tracing its origins back to the very beginning.
Through the compelling narrative provided in Genesis, the story of how everything began, we trace the path of the universe from its humble beginnings as a mere vacuum fluctuation to the vast and intricate celestial structures we observe today. Key moments in cosmic history are illuminated, such as the emergence of the Higgs boson and its role in creating mass, the birth of the first stars, and the formation of galaxies, including our own Milky Way. Ultimately, amidst this exotic cosmic stage, our solar system and the Earth come into existence. By demystifying these complex phenomena, the book leaves us with a deeper understanding of our origins and a greater appreciation for the grand cosmic journey that has led to the spectacular reality we know and inhabit today.